All right, this is Chapter 1, Lesson 5, Relations. So we're going to be talking about the coordinate graph. And in this coordinate grid, there are 4 quadrants. The first quadrant is positive, positive. Quadrant number 2, and they're all written as Roman numerals. Quadrant 2 is positive, negative. Quadrant 3 is negative, negative, and quadrant 4 is negative, positive. Okay. Generally, when you see quadrants, they're written as numerals. This box up here that's pointing towards the center of my 2 points is the origin. That's point 0, 0. Right here, where it's pointing to the dot, that is -4, 3. My x value is -4, my y value is 3. This box here that's pointing to this line is the x-axis. And this box here is pointing to the y-axis. All right, relations. A blank is any set of ordered pairs. Relations can be represented as a table and as a graph. The blank of the relation is the set of the x coordinates. The blank of the relation is the set of y coordinates. So in those blanks, you're going to write relation, domain, and range. Okay. So a relation is any set of ordered pairs. Relations can be represented as a table and as a graph. The domain of the relation is the set of the x coordinates. The range of the relation is the set of y coordinates. So, taking a look at a couple of examples, here are my ordered pairs. Okay? My domain, if you're asked for the domain, is just the set of x values. So in this case, the domain is -2, 1, 0, and 3. The range, if you're asked for the range, is the set of the y values. In this case, 3, 2, -1, and 1. Okay? They can also be represented using a table or graphed on a coordinate plane. So let's take a look at an example. I want to express the relation 2, 6, -4, -8, -3, 6, 0, -4 as a table and a graph. Then I want to state the domain and the range. First, I place the ordered pairs into a table. I make a T-chart, okay? So a T-chart is just one line that's vertical and one line that's horizontal, okay? And it just represents a list of items. At the top, you'll have X and Y, and then you'll list each of your coordinates. So 2 goes in the X, 6 goes in the Y, -4 in the X, -8 in the Y, and so on, okay? Then I'm going to graph those on the coordinate plane, which I've done so. So 2, going over 2, up 6, -4, down -8, going over -3 and up to 6, and 0, -4. The domain, remember, is the set of all of my x values. So my x values are -4, -3, 0, and 2, and the range is -8, -4, and 6. Okay? Notice that I have 2 values that are both 6s. I don't have to state both of them twice in my range or my domain, depending on where they are. So if you have 2 numbers that are exactly the same, you can just list one of them. For number 2, it costs $3 per hour to park at the Wildwood Amusement Park. Make a table of ordered pairs in which the x-coordinate represents the hours and the y-coordinate represents the total cost for 3, 4, 5, and 6 hours. So, my x values were given to me, 3, 4, 5, and 6, so I've gone ahead and made my T-chart. Okay? They told me that it's $3 per hour. So, 3 hours, it costs $9 to park, 4 hours, $12, 5 hours, $15, and 6 hours, $18. Then I went ahead and I graphed these on the number line. I went over to 3 and up to 9, over to 4 and up to 12, over to 5 and up to 15, and over to 6 and up to 18. I wasn't asked to connect these dots, you just leave them as points on your coordinate graph. All right, there are a couple try-it problems out below. I want you to go ahead, pause the video, and when you're done, we'll go over the try-it problems together. All right, now that you've had a chance to try out the try-it problems, let's go over the answers together. So, the first try-it problem I have is letter A. Letter A says, express the relation -5, 2, 3, -1, 6, 2, and 1, 7 as a table and a graph. Then state the domain and the range. So there are 4 things that I need to do in this problem. I need to create my table, create my graph, list my domain, and list my range. Okay? Doesn't matter which one you start with out of any of those 4. I'm going to go ahead and start with the table. So, I'm going to go ahead and fill in my table. All my x values will be in the x column, and all my y values will be in the y column. My first coordinate, -5, 2. -5 goes in x, 2 goes in y. Then I continue with the rest of my coordinates. Now that I have my coordinates listed, I'm going to head and graph them on my coordinate plane. So for my first one, I go over to -5, up to 2, create my point. I go over 3, up or down -1, create my point. I go over to 6, up to 2, and over to 1, up to 7. Okay, so there's my points on my coordinate graph. Then I'm going to list my domain and my range. You can just list it as D and R, but you want to use these brackets when you're listing domain and range. Okay, they kind of look like a little squiggly line. So my domain is all my x values, so I'm going to go ahead and list them. -5, 1, 3, and 6. Notice that I put them in order from least to greatest. You don't have to do that, but it's highly recommended that you do. Okay. My range, -1, 2, and 7. Notice that I used 2 twice. Okay, I only have it listed once. You can list it twice, but you don't have to. All right, the second try problem I have says a movie rental store charges $3.95 per movie. Make a table of ordered pairs in which the x coordinate represents the number of movies rented and the y coordinate represents the total cost for 1, 2, 3, or 4 movies. Then graph the ordered pairs. So the first thing I want to look at is they gave me my graph, but they haven't given me my table. So I'm going to go ahead and make my table. Again, it's a simple T-chart. Here's my x values and my y values. Okay? My x values represent the total cost for the movie, and they've already given me 1, 2, 3, and 4. In my original problem, it told me that they charged $3.95 per movie rental. So I'm going to do one movie was $3.95. 2 movies was $7.90. 3 movies was $11.85. And 4 movies was $15.80. Okay. I got these by multiplying 1 times $3.95, 2 times $3.95, 3 times $3.95, and 4 times $3.95. So my x values, my x coordinates represent the number of movies rented. It's always important to label your axes. And y represents the total cost. Okay? Then it asks me to graph my ordered pairs. So my first one is about here. 2 movies is $7.90. 3 movies is $11.85. And 4 movies is $15.80. Okay. So when I graph, I should have something that looks like this. All right. The next thing I want to talk about is actually representing relationships. So we talked about graphing relationships, seeing them in tables. There are different ways that you can represent relationships. So, tables, graphs, and equations. Recall that an equation is a mathematical sentence stating that 2 quantities are equal. A blank blank is an equation with a graph that is a straight line. Some equations contain more than one variable. So in those two blanks, you're going to write linear equation. So a linear equation is an equation with a graph that is a straight line. Some equations contain more than one variable. So let's take a look at a couple of examples. The first example I have says the table shows the number of liters in quarts of liquid. Write an equation to find the number of liters in any number of quarts. Describe the relationship in words. So if we look at this, here's the table that they gave me. 1 quart represents 0.95 liters. 2 quarts represents 1.9 liters. Notice that the change every time, the constant rate of change is 0.95. So the rate of change is the rate that describes how one quantity changes in relation to another quantity. The rate of change of quarts to liters is 0.95 over 1. They got this by taking 1.9 minus 0.95 divided by 2 minus 1. Okay, so they took two y values, subtracted them, two x values, and subtracted them, and then divided. Okay. So there are 0.95 liters in every quart. Let L represent the liters and Q represent the quarts. The equation is L, because that's the total number of liters, equals 0.95 times the quarts. Okay? So another way to think about this is, what do I need to multiply the Q by in order to get my value for L? So each time. So I multiplied each time by 0.95. So if I do 0.95 times 1, I get my L. If I do 0.95 times 2 quarts, I get 1.9, which is my L. Okay, so that's what you're doing each time. All right, for number 2, how many liters are in 8 quarts? So I use the equation that I just wrote, and I'm going to substitute in 8 for Q. Well, according to my equation, L equals 0.95 Q, and I'm asked for 8 quarts. I substitute in 8 for Q. 0.95 times 8 equals 7.6. So there are about 7.6 liters in 8 quarts. All right, for number 3, so the total distance Marlon ran in 1 week is shown on the graph. Write an equation to find the number of miles ran, y, after any number of days, x. So if you notice, he ran, for first day, he ran 3.5 miles. 2 days, he ran 7. 3 days, 10.5. 4, 14. And 5 days, 17.5. So the first thing I want to do is I want to find the rate of change, or the slope of the line. So my slope definition is y2 minus y1 divided by x2 over x1. So I pick any 2 points on my line. We've picked 2, 7, and 4, 14. Okay? Pick them. They're nice, easy numbers to deal with. Okay? I'm not dealing with additional decimals or fractions or anything like that. They're whole numbers. So I subtract my 2 y values. 14 minus 7 gives me 7. And I subtract my 2 x values. 4 minus 2 is 2. When I divide 7 divided by 2, I get 3.5. So that's the slope, or my rate of change, for my equation. Step 2, I find the y-intercept, so where the line crosses over the y-axis. To find the y-intercept, use the slope and the coordinate of a point to write the equation of the line in slope-intercept form. Y equals mx plus b. Well, y equals 3.5. Remember, I already found the slope. M equals slope, x plus b. Then I replace the x value and the y value with any point that I know is on my line. Okay? In this case, I replaced it with the point 2, 7. So I place 2 in for my x, and I substitute 7 in for my y. 3.5 times 2 is 7. So then I subtract in order to figure out what b is. Well, 7 plus something has to be b. 7 plus 0 is b. So the slope is 3.5 and the y-intercept is 0. So the equation of the line is y equals 3.5x plus 0, or y equals 3.5. Alright, on the next page there are two try-it problems. I want you to go ahead, pause the video, and when you're done we'll go over the answers together. Alright, now that you've had a chance to try out the try-it problems, let's go over the answers together. So, for the first try-it problem, I have the total cost of tickets to the school play is shown in the table. Write an equation to find the total cost of any number of tickets. Describe the relationship in words. So, the first thing that I want to do is I want to look at my cost for my tickets. For one ticket, it costs $4.50. Two tickets is $9. 3 is $13.50, and 4 is $18. So I want to find what my constant rate of change is. So I'm going to take 9 minus $4.50 and divide it by 2 over 1. So I took two of my x and y values. I took this one and this one, okay, and I subtracted them. So 9 minus 450 is 450. 2 minus 1 is 1. So that tells me my slope, or my constant rate of change, is $4.50. Okay. So when I set up my equation, y equals mx plus b, I know that my m is 450. Okay. So then I need to figure out what my y represents and what my x represents. Okay. So in this case, total cost of tickets to the school play is shown in the table. So what am I doing? I'm multiplying 450 by something in order to get my cost, right? So my cost, my x value is the number of tickets, t, and my y value is the cost, the total cost, c. So my equation is c equals 4.5, or 450, t. This represents that each ticket costs $4.50. Letter B asks me to use the equation that I've created to find the total cost of 15 tickets. So for letter B, I substitute in 15 for my t value. 450 times 15 gives me $67.50. So if I got 15 tickets, it was $67.50. Alright, for letters C and D, the number of trees saved by recycling paper is shown. Write an equation to find the total number of trees Y that can be saved for any number of tons of paper X. Use the equation to find how many trees could be saved if 500 tons of paper are recycled. So, in this case, I want to find my slope. So I pick any 2 points on my line. I'm going to pick 234 and 117. You don't have to pick these points. You can pick any 2 points, but I'm going to pick these because they're going to be easier numbers to deal with. So I'm going to find my slope, which is taking 34 minus 17 divided by 2 minus 1. So I get 17 over 1, so that's my slope. So y is the total number of trees, 17, and then x is my paper. Then I'm going to use this equation to find 500 tons of paper. How many trees can I save? So x represents the tons of paper. So y equals 17 times 500. So y equals 8,500 trees. Alright, so there are multiple representations of linear equations. You can use a table, a graph, or an equation to solve them. So, multiple representations of linear equations. So in words, distance traveled is equal to 12 miles per second times the number of seconds. So in my equation, I can do d equals 12s, where d represents the distance traveled and s represents the number of seconds. I can do it as a table, where x represents my time in seconds and d represents my distance, or I can do it as a graph. There are a couple more try problems below. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, these are my last two try it problems. So now that you've tried them, let's go over the answer together. So for letter E, it says financial literacy. Paul earns $25 for grooming a dog plus $18.50 per day for boarding the same dog. Write an equation to find the amount of money Paul earns M for grooming a dog once and boarding it for any number of days D. Okay, so first things first, I have a table here. Okay, my table is going to help me figure out my values for X and Y. So for X, which represents the total cost, or the total days, okay, my equation is going to be 25, because that's the amount of money that he earns for grooming the dog, and he groomed the dog, okay? So 25 plus every day that the dog stays, it's $18.50. 18.5 times D. And that will equal the total cost. Okay. That's the total amount he earned. So let's say he stays 5, 6, 7, and 8 days. Okay. So my equation that I've created is 25 plus 18.5D. Okay. So for letter F, it says make a table for his earnings for 5, 6, 7, or 8 days, then graph the ordered pairs. So for 5 days, I have 25 plus 18.5 times 5. For 6 days, 25 plus 18.5 times 6. For 7 days, 25 plus 18.5 times 7. For 8 days, 25 plus 18.5 times 8. Remember to use order of operations when you're solving these. So when I solve all of this, for M, I get $117.50. For 6 days is $136. For 7 days, I get $154.50. For 8 days, I get $173. So D represents the days the dog stayed, and M represents the total amount of money. So if he stayed for 5 days, the dog stayed for 5 days, Paul earned $117.50. Go over to 5 and up to $117.50. 6 days was $136. 7 days was $154.50. 8 days was $173. So you can see the longer the dog stayed, the more money that Paul is actually going to make. He's only going to groom the dog once during that time, but he makes more money the longer the dog stays. All right, and that is the end of Chapter 1, Lesson 5. It's also the end of Chapter 1.